Okay, how about the remaining people? 6 of you haven't answered this one. Right. Now for this one, the main point is that if you look at that, it is about batteries, okay? And then quality of the batteries, okay? It means see uh, whether the batteries are good enough. And therefore, in this case, first of all, A and C must be wrong, okay? Because you cannot interview the batteries, right? And this one, observation is not really good. Of course, you may think that um, I can put the battery to some, for example, a toy, okay, and then see how long the toy can last, okay. I mean how long the battery can last. But this kind of observation is not accurate enough. And then you can see in for this one, you're asking the best way, okay, best way. Okay, observation can be one way, but I think in this case, experiment will be better. Okay, therefore, I think most of you have got this one correct. Okay, right. And then for the next one, okay, right. And then for the next one, which kinds of data, okay, which kind of data, okay, are the following? Let's see whether I can do something like that. Hey, oh, okay. Number 26. Which kind of data are the following? First one, the finishing time of the first 30 ethics in a bicycle race. Now the key point is this one, the finishing time. And then for second one, the number of ethics athletics from different countries in a bicycle race. In this case, these are the keywords, the numbers of something. Therefore, you choose one means here, okay, whether one is discrete data and two is discrete data also. Uh, Part B means you choose first one should be discrete data and the second one to be the continuous data. Okay, right. You can choose your answer now. How about the others? Only 11 of you have finished. How about the others? Quickly choose questions. Okay, this one. Okay, three of you. I think three of you haven't choose the questions and choose the answers. Okay, whether okay. Let's see. Some of you, some of you has chosen A. Okay, both are discrete data, and then and some of you have also chosen B, and then most of you chose C, and then also some of you uh, choose D. Now, first of all, um, this one, this one D is not really correct because if it is a continuous data, now we are talking about the number of athletics. Athletics are the people uh, who do the sports, who do the exercise. For example, uh, if you are the one who um, participate in a football competition, you can be also called an athletics. Okay, therefore in this case, these are people. Okay, but the numbers of, okay, it means I can count how many people are there, okay, who participate in this bicycle race. Bicycle race, it means you ride the bicycle and see who can go faster, okay, bicycle race. Okay, therefore in this case, the numbers of, then you, when you are asking how many participants are there, then you need to count 1, 2, 3, 4, 5, right? But can you have 1.5 people? We cannot. Therefore, we can just 1 and 2. And then in between, okay, between these two numbers, we can't have these values as the data. Therefore, it is not continuous data. Because the second one is not continuous data, then in this case, of course, option B is also incorrect. Okay, because the second one is not continuous, right? Okay, now then the remaining two, C and option A and option C. Now then you should know the meaning of discrete data and continuous data. Just now, for discrete data, it means the data, for example, 11, 12, 13. It means I can have 11, I can have 12, but the values between these two numbers, for example, 11.5, 11.7, 11.893, and then we cannot have this value. Then in this case, this is discrete. Therefore, you have to remember the meaning of this word. Therefore, discrete data is always related to counting. Because when we count something, we count, okay, there are 1, 2, 3, 4, 5, something like that. And therefore, this one, the second one is discrete. Okay, but for the first one, finishing time can be continuous. It depends on the one to the instrument for measuring the time. We can have 1 second, right? But we can also have 1.23 seconds. If I have an instrument which is very accurate, then maybe I can have 1.2457 like that. Then it means you can have any numbers. You can have any numbers. Therefore, in this case, this one is also incorrect. Therefore, the correct answer is C. Okay. What is the data is make sure. what do you mean? Okay. And then for the next one, okay, question 27. We have, according to the frequency distribution table, okay, and what percentage of the data have values less than 15? You need to calculate the percentage. Therefore, in this case, first of all, you need to find the total. You need to find the total, okay, and then find the number, okay, which are less than 15. Okay, you can this one. Okay, what total frequency? What is the total frequency? It means when we are talking about total, we need to find the total here, the frequency. This one means for this value, it appears 10 times, 12, 12, 12, 12, something like that. That is the frequency, okay? And then in this case, you are asking to find the percentage of the data. Therefore, first of all, what is the total frequency? The total frequency will be 10 plus 7 plus 9 plus 11 plus 13, okay? And then what's that? It is 50, right? 50. Okay, thank you. And then you need values less than 15, less than 15. Therefore, look at these. And then this part, it means I have number of values less than 15 equals 10 plus 7 plus 9, right? Which is 26. And then you are asked to find the percentage. Therefore, the percentage will be 26 over 50 times 100%. Therefore, which is 52%. Okay, right? Any problem with this one? Okay, then come to the next one. And then this time you have the pie chart. And then shows the types of books in the bookstores, different types of books. And then if there are 350 fictions books, okay, this part, okay, 350. Okay, and then find the total number of magazines and comics. Magazine and comic. The others waiting for you quickly. What do you think? Save. This one may need a bit more calculations, I think. I think you may, let me see. You may need to find the total number of books, I think, right? 350 is the number for fiction, okay? And then if you look at the pie chart, for fiction, the angles of the sector, which represents the fiction books, is 70 degrees. And therefore, in this case, do you think you know how to find the total number of books? Uh, Class monitor, I think you need to, could you, if you, after you finish this one, please count the number of classmates, your classmate, I mean, because many of you are not here. There are only 21 of you, I think. Okay, have you all finished? 17. Still need to wait for the other, some of you. Five or six of you haven't finished this one. Now, I think I would do something like that. I don't know whether you use the same method. Now, if x, okay, or maybe I just write as usual. I will think in this way. Okay, all the books, okay, x be the number of books, okay, in the bookstore. And then in this case, okay, for fiction, out of 360, it consists of 70. Okay, because the whole circle represents the whole, represents all. Okay, therefore, all the books together, okay, in this circle, okay, the angle will be 360 degrees, okay, for a complete circle. And then for this one, it is 70 degrees, right? Therefore, it means if x is the number of books, okay, when I use x times this fraction, then this one should be 350. Now, therefore, in this case, I can know that there should be total 1,800 books. Okay, all together, okay, all together, okay, 1,800 books. Now, therefore, in this case, okay, this one is 350. I can calculate the number of dictionary, which is 1,800 times. For this one, the angle is 20 degrees, 20 out of 360. Okay, therefore, in this case, Okay, there are, uh-oh, what's going on? There are 100 dictionary. Then in this case, you can continue in this way. For textbook, there should be 600, right? Okay, and therefore I would like to know the number of comics and magazines. Then in this case can be calculated by using 1,800 minus 600 minus 350. Minus 350 and then minus 100. Okay, therefore in this case, what do you think? Which one would be the answer? Okay, this one, 750. Okay. Uh, any other method when you calculate this one? Now, yes, I think now there can be another method. Any suggestion? Now, I now if you look at here, this one is 20 degrees. This one is 70 degrees, right? This one is 120. Therefore, in this case, for magazine and comic together, okay, and then together for the setter, oh, don't I think someone has turned on the video. That's why my screen is moving now. Mm, don't turn on your video, okay? Anyone who is that? Now then in this case it means for this angle and these angles together should be 220 degrees. And then you can also calculate the number by using proportion. Okay, it means if 70 degrees, this one, okay, for this case, it represents 350 volts. Therefore, you can calculate how about 220 degrees. Okay, how many volts are there? They should maintain the same proportion. They should maintain the same proportion, right? Am I correct? Oh, the degree is wrong here. 170. Right. Okay. Oh, I forgot to minus an angle. That's why this one should be 360 minus 112, 120 minus 70, and then I forgot this one. Oh, sorry. The angles, these two together should be 150 degrees. Therefore, in this case, if 70 degree represent 350 volts, And then how about 150 degrees? And then they should maintain the same proportion. They should maintain the same proportion. Therefore, in this case, this question mark can be calculated by these relations. Okay, it means when I use 150 divided by 70 here, 150 divided by 70, I can calculate how many times here. Okay, and then they should maintain the same multiple, or it means when the angle is double, then the number of books should also be double, right? And therefore, 100, if I look at this angle, the angles in the sector, if I use 150 degree divided by 70, should be equals the number of books for this angle divided by 370, 350, okay? Because this we are given that this part is 350 books. And therefore, in this case, you can just solve these equations. And then you can have this question mark equals 350 times 150 divided by 70. And then you can do some cancellation. And therefore, 5 times 150 also 750. Okay, it means there are several ways to do this one. Okay, you can either find the total number of books and then subtract each one, or you can use this kind of thinking, use the proportion. Right. Okay, then this one. And there's a stem and leaf diagram here. Okay, and then it shows the mark scores by 25 students in a test. Okay, and if the passing mark is 50, and then you are asked to find the percentage of people who can pass the test. How about the others? Now, then in this case, it means if you look at the data, one student has 44 marks, one has 46 marks, one has 47. And then we have 50 marks, 53, 55, 55, and then 57, okay, etc. And then the passing mark is 50. Okay, who have passed the test? Passed the test. Okay, half of your class have answered the question. The remaining half, you just count the number of people who passed the test. How many of them can pass the test? There are 25 students. Okay, and then you count the number who passed the test. How about the others? Quickly. For you need to train your speed to do the multiple choice question. You cannot spend too much time in multiple choice questions. Otherwise, you don't have enough time for the other questions. That's why you better keep yourself to be able to finish one multiple choice question within a minute. It means you better just spend only 1 minute in one multiple choice questions. Otherwise, you may not have enough time for the others. Right. Now this one, if you just 50, just look at it, 50 marks is the passing mark. Therefore, it means they failed the test, right? They failed the test. It means 3 failed. Then the others passed. Therefore, total number of students will be 25. Therefore, in this case, 22 pass the test. It is easier to count the number of people who failed the test in this case. But for multiple choice, you don't need to show the steps. Therefore, you can quickly know that the number here on top should be 22. And then you are asked to find the percentage, okay, times 100%. And then you should have done this one before. Okay, 100 is 4 times of 25. And therefore, in this case, 88%. Okay? Right. Then we come to the next one. Oh. Okay, this one. You are asked, okay, there are several diagrams for, okay, and then you are asked which one, okay, is the best, right, to show the changes in blood pressure. Okay, changes in blood pressure of a patient. Which statistical diagram? Do you know the meaning of blood pressure? Now, usually, if the patient is in the hospital, okay, the nurse usually measure the blood pressure for the patient regularly. For example, every hour. Okay, it means the nurse may measure the blood pressure of a patient, say, every hour in the hospital. Or some patient may need to see the doctor regularly, for example, every month to measure the blood pressure. Therefore, in this case, you can imagine that when we collect the data, we may have data like that. You may have a record like that. For example, if the blood pressure is measured monthly, then you have January, okay, a number, February, another number, March, okay, April, etc. Then in this case, for these kinds of data, what do you think? Which diagram is more suitable? It's more suitable in this case, okay, to a pie chart. Do you think pie chart is good? But usually for the patient, we need to measure the blood pressure for a very long time. Okay, these are only the examples. Then maybe May, June. Okay, you keep measure the pressure in this case. But by the way, do you know the meaning of blood pressure? Hmm, let me show you this one. Can you see the picture here? Can you see the picture? That is the picture when one is measuring the blood pressure for a patient. Can you see that one? Here. Have you seen this before? That is blood pressure. Or some people may use this one to measure the blood pressure. Okay. Therefore, in this case, what do you think? Do you think that it is good to use a pie chart in this case? Hmm. Stem and leaf diagram. Then there would be a problem that if for some people, if it depends on where you take the data. If this is the case in the hospital, then stem and leaf diagram may not be good to do so because they need to do it quite frequently. It means in some cases the measurement, this one, maybe need to take for every hour. Therefore, in this case, for just one day, you can imagine for just one day, okay, you have 24 data already, okay, and then if the patient stay in the hospital for several days, then you can imagine that it is quite difficult, okay, to do the stem and leaf diagram. And also because that for stem and leaf diagram, you need to arrange, okay, arrange the data. It means if you look at this one for stem and leaf diagram, can you see that for this one? It means you need to arrange the data from small, okay, to the bigger value. But I think in this case, when you are taking care of a patient, you can imagine that I want to know for the blood pressure, whether it goes up sometimes or go down sometimes. Okay, whether it continuously to be very high or after taking the medicine, it goes down like that. Therefore, in this case, I don't think stem and leaf diagram is a good choice in this case. And also for pie chart, if for the case of pie chart, there's another for this one. Now, we need to, percentage is good, but the case is that we have to draw the diagram after we have finished collecting the data for pie chart. Then it is not the case in the hospital. It means if for today, okay, you have 24 data, right? And then you draw a pie chart. But tomorrow, you will have more data. Then in this case, you have to calculate the percentage all over again and then draw another diagram. Do you know? It means every time you take the measurement and then you have one new data. And then the percentage will be different in this case. And then you have to draw the pie chart again every time when you have a new data. Therefore, I don't think pie chart is good. Although you may think the percentage is good, but if you are the patient, it's for our patient, okay? If you want to know whether your blood pressure is going up and down, is it good to know the percentage? It means the percentage of the day that your blood pressure is high, something like that. Think about it. And then for scatter diagram, but scatter diagram usually it is used for looking for relations. I should write more clearly, right? Now, if you don't know the meaning of these words, you should look up from the dictionary. Don't always say that I don't know this word, I don't know this word. You can look up in the dictionary, or you can look, actually I think you can just look it up in your phone or in your computer. If you come across some words that you don't know and then you don't look up the meaning, then you can never learn the words. Now for relations, it means if I want to know blood pressure and smoking, if I want to know whether smoking can cause high blood pressure, then in this case, I may use scatter diagram. Then I may take the record that the blood pressure of a person, and then how many times he smokes one day, and then I can get a scatter diagram to tell whether smoking can affect blood pressure. But this one, I just want to know the changes, whether it goes up and down uh, uh, over time. Usually when we talk about changes, it means at this moment, okay, the blood pressure say is 60, and then next hour is 70, and then next hour again maybe 50. And then I can know the change, okay, go up and down, something like that. Therefore, in this case, I think most of you have chosen the correct answer. Okay, I believe that broken line graph is much better. Because for broken line graph, for this one, we usually have time here. Okay, the time, can be hours, can be days, can be weeks or months. And then therefore, in this case, I can have a graph like that. Say now it is May. I can take my blood pressure and then put upon here. And then next month, June, I take my blood pressure, then I can add a point here. And then we can continue in this way. And then you can add new data in this way. After you have gotten new data, then you add a point. Okay. Then in this case, you can, after you have got the points, and then you can draw the line, remember? And then we know the change. We know the changes. Okay, how the data change over a period of time. Okay, any more questions in this case? Therefore, broken line graph for this one. Now you have to, when you look at that, when you have a question asking you to choose a suitable statistical diagram, then you have to think about if you need to collect data. Okay, what kind of data you have, and then whether you can have the data to draw the diagram. Okay, right. And then should be one more multiple choice question at the back. I mean, there is question 31. And then should be like this. Here, this part is question 31. Okay, right. And this figure shown in the advertisement, okay, and then body fitness by a body fitness company, and then which of the following are the misleading parts in the given statistical diagram? Okay, then you can look at the options one by one. Now for this one, now first one, the bars are of uneven width. Okay, you can look at it. It looks like the bar. Looks like bar chart. Okay, this part is the width. Uneven means the width. Every width is different. Okay, not the same. Not the same. Uneven. Not the same. And then part two, the second one, the total number of customers used in the calculation of each percentage is not shown. Then you can see in this case, okay, body fitness company satisfactory level. Body fit, okay, you can see that the temperature is quite, it's not bad, 60 something, and then visual very high percentage, 80, and then fit fast, okay, 60. Okay, the percentage, all of these percentage are quite good. Okay, I mean not very low. Okay, then does this means that a lot of people, okay, a lot of people satisfy, okay, in this case. And then number three, the vertical axis does not start from 0%. Okay, therefore, which one? Okay, which one here? 1, 2, 3. Which one you think? Okay, that they are misleading. It means this diagram is misleading people. And then why? The reason. Which one? Which one amongst these three you think that are the reason? Okay, most of you, okay, most of you chose B. And 1 and 2. Okay, how about the others? Just 15 of you have answered. How about the others? Quickly. 16. Anyone who haven't finished? Seventeen of you. Eighteen of you. I'm waiting for the others' answer. The other ones who haven't answered. Who haven't answered. 5 of you haven't answered. Okay. 4 of you. Who are the 4 who haven't answered this question? Okay. Right. Still waiting for 2. Okay. Now, most of you, let me see. Some of you think that the answer should be B, and then some of you think that it should be D for dog. And then the difference is that this one, okay? It means some of you think that this one is not important, the total number of customers. Now, if you look at the diagram again, do you know the total number of customers? Actually, this kinds of diagram always, they are very common. You can always see them in the advertisement. I mean, you can watch similar TV commercial. I mean, see, you can watch these kinds of um, um, advertisement in the TV, and then someone will say that most people, or 90%, over 90% of people think that it is good, or maybe it is quite common in toothpaste advertisement, and then 90% of the dentists recommend this toothpaste. Have you seen these kinds of advertisement before? Now, what is 90%? Is this in this case? Now, what happened? What happened if there are only, for example, if the total number of customer used in the calculation, if there are only 20, if there are only 20, and then what is 90? What is 80%? It means just 16, right? 80% of 20 is just 16. It means for this kinds of product, let me see, fits all or fitness company. It means amongst these 3 fitness company, okay, just 16 people, okay, tells you that fits all is really good, but there are only 16 persons only. And then maybe a few of them, okay, a few of them say this one, a few of them said these two are not good. But even this one has the highest percentage, but if the total number of people is 20, it means just 16. Or in some very extreme cases, if the company, if the person who did the survey, okay, just ask 10 people, then it means 80% means just 8. Okay, it means just 8 people think that this company is good. Then do you think that the total number of customers is not important in this case? I mean, if you don't know the total number, if you look at the diagram, will you believe that okay, this company is the best? But then later you find out only 8 people think that it is the best. Do you know what I mean? It means if the total number is 10 or the total number is 1,000, then there is a great difference in this case. For total number 10, 80% will be just 8. But if the total number is 1,000, then in this case, 80% will be 800. Therefore, it means just 8 people tells you that this company is good, or 800 people tells you that this company is good. It is already a kind of difference. Okay, therefore, in this case, this one is also important. Okay, the total number of customer in this case is hidden. Therefore, it is also a misleading part for this diagram. So I agree with option D in this question. Okay, right? Anyone, okay, anyone don't understand why it is D instead of B? We have to include this one. Okay, right. Then for number 12, for chapter 12, anyone have other questions or any part, okay, of chapter 12 that you think that you don't understand?